Okay, so today's video is going to be about string theory. Okay, so to get started with, let's start with gravity. Okay, so let's get started with gravity, which shows that at level, at quantum level, which doesn't exist. Okay, it only exists in um, level which is uh, macro level. So, what I want to say is, we know that gravity, what Einstein said about gravity is that it is fabric of space-time, fabric of space-time, in which if you put a mass, a certain amount of mass like our sun, that fabric of space-time will bend. Okay, at macro level, gravity is the strongest force. Okay, its property, strongest force, strongest force. Okay, and on the contrary, this same force is the weakest in quantum mechanics, or not quantum mechanics, in the standard model of in the standard model. It doesn't fit. You cannot fit gravity because of it being weak. At quantum level, it's weak. It doesn't exist. Plus, at quantum level, we take gravity. Wait, let me write standard model. Standard model. Model. Okay, so then, um, at quantum level, at small level, it's given the name gravitons. Gravitons. Okay, and it's still a theory. Okay, it's still a theory. Okay, so um in standard model, there are three components. Third one I'll show you, one, not three. For now, let's make it two, because third one I will add later, because it's there's a problem, so we can remove it easily. One is fermions. Second is uh, bosons, the WZ bosons. Okay, and fermions are for matter, bosons are for interactions, every kind of interaction: magnetic, radioactive, and then electric, and so on. Fermions have spin, they have spin of half. Bosons have spin integer, integer bit full, integer. Okay, and so it's positive, negative, and positive, negative. And so, for example, in bosons we have photons. Okay, photons. And so, uh, yeah, so what we have a problem here is that when we talk about string theory, because one of the problems in physics is that we are not sure how to sum up everything. How can we like include every single theories as one? How can we combine all theories? Combine all theories. Okay. So then here we introduce uh, here we introduce string theory. So what things string theory says? String theory says everything at everything is made of strings. Strings mean vibrating things. Strings vibrating. Sorry, pardon. Vibrating strings. Okay. So what do I mean by vibrating strings? So let's suppose if this is a string, okay, and then this is one more string, and then this is one more string. So what we notice is that this string could vibrate in this one string dimension. This string could vibrate like this. I'm just giving example. This string could vibrate like this. So each frequency vibration here, each vibration here represents represents a particle. Okay, it depends represents a particle which are only bosons. Okay, they all are bosons, but we don't have any vibrations for any like model for vibration of fermions. Okay, and we have bosons. Okay, so what we do, because that's one of the three problems, one of there are three problems which we will discuss, and this is one of the three problems. The other two will discuss later. One of the three problems, okay, which is that we have bosons, which bosons do have the vibrating strings. We can define bosons as strings, but we don't have the theory for fermions, the how what type of vibration string they have. This is the first problem. The second problem is that there exists one more there exists more uh, one more region, okay, and that is tachyon. Ta- Tachyon, okay, and this tachyon has um, the property that it's the mass of it is -1, a square root of -1, which is an imaginary number, okay, an imaginary mass. The third problem of string theory, or third problem of string theory, when we add string theory plus, now one more thing, we are adding gravitons here. How we could describe gravitons? Okay, gravitons. Okay, because of adding gravitons, we have to be careful of the strings. We have to be also careful of the we don't have the string, how the strings behave in fermions, the matters, how when we have tachyon, another mass, another region which has a mass of negative, which is an imaginary mass. And the third problem is that this string theory now works in 22 dimensions. Imagine 22 dimensions. And till now we only have 4 dimensions. and this theory wants us to discover about 22 dimensions, right? So what we do is we have a solution for this. Okay, so we have a solution for this. What? To define strings, or to define fermions as string theory, we make it superstring theory. What we'll add is superstring theory. For this, fermions, we add something known as spinners or spanners. Okay, we add what we add spanners or spinners, whatever it's called. Okay, if we add these on this, so we add spanners, spinners or spanner. What was it? Spinners? I think, yeah, spinners. So then this now solves the problem of fermion, and it also cancels this problem tachyon. We now don't we can remove this field tachyon. Third problem which is solved, which we had, was it that thing works in not 22, 26 dimensions, right? Now because of adding superstring theory, we have got it down to 10 dimensions. 10 10 dimensions. Okay, so then what could we do? Yeah, we have simplified it to such a low point, but still we are stuck with 22 10 dimensions, and we only know how many dimensions. How many dimensions we know? We only know um, 10 dimensions. Okay, so what could we do? Because what we know is that 4 dimensions we already know, the coordinates x, y, z, and time. These are the 4 coordinates, 4 dimensions. Okay, so what could we do? There is some alternatives to this, how that we could be living in in a such in a field which consists of multiple dimensions, that our dimensions are not that, like, there's such like a level that we these dimensions are within the other 6 dimensions. Okay, dimension within within dimensions, that's what I should call it. Sorry, I'm not feeling well, that's why. Then second of all, it could be that um it could be that these dimensions are they exist but we don't see them, because when we are like looking at, let's suppose we are looking at certain thing, and when we see it from near, it has maybe more than 2 dimensions, or one dimension, more than one dimension. But when we zoom out, we are we lose so much of the information, we lose so much information, so much information. Okay, okay, so one more thing, in uh, in smaller at quantum level, there's something known as superposition. Okay, and one of the properties of string theory is that, not string theory, one of the properties in the normal thing is that when we talk about an electron being shot and there's a target and we have to shot the target. When electron is shot from it, it acts as waves. Okay, it acts as waves. Okay, it acts as wave. Okay, one of the properties is that it will travel in all paths when, because of first superposition state. This is something else superposition. Take all paths. Okay, so to to get the probability of the position of the position. Okay, we need to take in account of all the paths. We take all the paths. Okay, and then we get, in the end we don't get the exact location. We only get probability. Maybe over here it would be 27, here 10, here 15%, percent. Okay, so then what could we do? String theory here helps us decrease so much of the problem. String theory. Okay. Sorry. As string theory, it doesn't travel in just one line. It travels in taking a certain surface area. Okay, so, and when it takes multiple positions, takes multiple paths. What happens is that if it splits, when it takes paths, it takes multiple, it spreads out. At the point of spreading, it releases any energy. It releases for in particle. At the point of re connection, it uh, absorbs that particle. Okay, so here, whatever path it will take, that path will be um, add up added up added up. Okay, it makes it easier for the calculation to happen. Now, instead of taking every single path as a line, we are taking every single path as, so what we say is that it is taking on all of the path, and as a path it's traveling as a surface area, so it's much easier for us to calculate. Now, so string theory is one of the promising theories, and when we compare it to field theory, which says that everything in this world is in terms of field. Okay, and interaction between a field, every particle is a field. Boson is a field, and this is matter is also field. Every particle has a field, and interaction between the fields, this is one of the enemy theory of string theory. So, and even this theory is very good, but one of the promising theories, string theory. String theory has upper hand, in my opinion, because it explains most of the problems. Because including string theory includes Gravitons are possible in the string theories, but because if we look at everything as particle and adding gravitons to like equations, when we do calculation and we add gravitons, the value we get will be infinite, and that's not possible. Okay, it's not possible. So including including string theory, we can say that we can say even gravitons has certain frequency waves, waves or strings, just like guitars strings have multiple waves. Look, if let's suppose if we have this theory, this string, how many oscillations? Number of oscillations one. This number of oscillation two. One, two, three. Okay, I just made one more extra. Number of oscillation three, and it goes on. So that's the benefit of string theory. In terms of string theory, we do get the luxury of simplifying things. Okay, and because the benefit of adding string theory is that it helps us add gravitons as one of the particles in standard model or standard model. Okay, model. Thank you.